Okay, my precious little mathematicians, welcome to finding the rule for linear relationships. So, how to look at Cartesian planes, how to look at plotting graphs, when we were given the rules, now how do we do it by ourselves, and how, more than that, do we find the rule for linear relationships. So, just need to put a heading in your book, finding the rule for linear relationships, and writing this down, guys. All I'm saying is, when coordinates follow a linear pattern, you should already know this, a rule can be found for that pattern. That rule will work in every coordinate in that pattern. So we've kind of looked at that. You've looked at that. You've established that idea. Today you are going to learn about how you actually find that rule and derive that rule from the value tables that you've been given. So we've kind of had a bit of looking at Cartesian planes and looking at rules that we were already given. Now today you're going to learn about how to actually find the rules for the linear relationship. So, our example here says, find the rule for these set of points. Now, these points form a linear pattern. I've actually given you the solution over here, okay? So, we actually have the solution. But, say we weren't given the solution. Say we didn't know what this was. And all we were given, instead, was this values table. Sorry, let's just, Mr. Corsi, rub this out. Okay, say for example we weren't given this solution and all we were given was this values table over here and we were asked to find the relationship. What you are doing here, guys, all you are doing to find the rule is to look what is the connection between x and y. What is the connection? First step, ignore the negatives. Ignore the negatives or the zero values over here and look at the ones and the twos. Look at the positive numbers. That's the first thing we do. So where x equals 1 and above, look at them and try and find the connection. Now, first off, try adding and subtracting. What's the connection between 1 and 3? Okay, so that's adding 2. Okay, so if x is 1, y is 3, all we've done there is added 2 and jot that down. X plus 2, y equals x plus 2. Okay, then the next thing we do, once we've come up with this idea, is look at the connection between the next set of numbers in the thing. So, if x equals 2, y should equal y plus, hey, look, that's plus 2 as well. So it works for that one, it works for that one. Now let's try our negative numbers. Okay, if x is that plus 2 is 2, minus 1 plus 2 is okay. Well, if it works for all of my solutions, it therefore must be the rule. All we're doing, guys, is looking for the connection. Don't get yourself confused. All you're trying to ask is, what is the connection between x and y? What is the connection? It's just a matter of inferring. There's no right way to go about this. It's just a matter of looking at them and saying, what's the connection? So find the rule for these set of points. The rule would be y equals x plus 2. We know that because not only did it work for one solution, but it worked for all solutions, and we tested all solutions. That's how we find out the rule. Look, and if we look here and we plot them, it does indeed equal y equals x plus 2. So this is just a Cartesian plot of this values table. Get used to using this language, guys. Cartesian plane, values table. How do we work out the rule? We look for the connection. What is the connection between these two numbers? Let's now have a look at a bit more of a tricky one. Okay, let's have a look. Find the rule, guys, for these set of points. Now, this table looks a little bit tricky. Step 1, as always, let's just ignore these negative or zero base values because they're going to confuse us for the moment. So, we look at the positive numbers. We look at these guys here. So, again, what we are trying to do here, we're not trying to perform big time operations. All we're trying to do is ask the question, what is the connection between x and y? How are they connected? What's the relationship between them? How do we do this? Trial and error. So, last time we added 2 and that seemed to work for us. So, let's have a look at this first example. When x equals 1, y equals 4. There's 3 difference from that, so maybe that's x plus 3. Let's look at the next one over here. 2 and 7, 2 plus 3, 5. No, that doesn't work. Okay, so that's not really working for us. So let's try multiplying. Okay, let's try multiplying by 2. 1 to get to 4. 2 multiplied by 2 and add in 2. That works. So 1 multiplied by 2 is 2 plus 2 is 4. 2 multiplied by 2 is 4 plus 2. No, that's 6. That doesn't work. Okay, let's try something else then, guys. Let's stick with this multiplication, but maybe let's try 1 times 3. So 1 times 3 is 3 plus 1. So x times 3 plus 1. That could work, yeah. Because 1 times 3 is 3 plus 1 is 4. 2, let's have a look over here. 2 times 3 is 6 plus 1 is 7. Hey, I think we're on a winner here. 3 times 3 is 9 plus 1 is 10. Boom, we've got it. So, how do we know we're on the right track? When 1, 2, 3 match. Guys, do you see the way I explained that to you? Do you see how I was talking it out? So I was just testing in my head. 1 times 2 is 2 plus 2 is 4. Yeah, that works. It's a matter of trial and error. I explained it to you this way because this is the way I want you guys to think when you're approaching these problems. Look at them and just try testing them. Talk to yourselves. Talk to one another. Talk out loud. That will help you. All you're trying to do here is find what is the connection, trial and error. Now, this is our idea. So we've times x by 3 and we've added 1. We've come to the solution. With 0 here, 0 times 3 is 0, plus 1 is 1. 1 times minus 1 times 3 is minus 3. Minus 3 plus 1, come back, minus 2. So it works. So the rule for this one is y equals 3x plus 1. That's all it is, guys. That's absolutely all it is. It's not rocket science. It's just looking between the x and the y values and saying, what is the connection? How are they connected? And then looking at different operations in order to come to an idea, and then testing by saying, yes, it works for this. Yes, it works for this. Yes, it works for this. It's just trial and error, guys.